What if beyond the twinkling stars and the silent dance of planets, the universe is whispering secrets waiting for us to listen? This documentary embarks on an extraordinary journey to the frontiers of the cosmos, where anomalies defy explanation and the known laws of physics. Our voyage begins beneath the icy surfaces of distant worlds, where hidden oceans might teem with life forms unlike anything we've ever imagined. What mysteries do these subterranean seas hold, and could they be harboring evidence of life beyond Earth? Then we explore the silent expanse of space, a place where sound is thought to have no medium to travel, yet the universe vibrates with unseen energies. How can we translate these vibrations into a language we understand? And what do they reveal about the cosmic symphony that surrounds us? Our curiosity leads to the discovery of planets so bizarre they seem ripped from the pages of science fiction. Imagine worlds where precious gems rain from the sky, or where darkness reigns eternal. What do these extreme environments tell us about the diversity of the universe and the potential for life in the most unexpected places? When we turn our gaze to mysterious visitors from other star systems, objects that pass through our cosmic neighborhood, leaving scientists puzzled and intrigued. Are these just wandering fragments of distant worlds? Or do they carry secrets from the far reaches of space? And finally, we contemplate the fate of stars on the brink of cataclysmic transformation. The universe is a stage for spectacular events that occur over millennia. But what happens when we witness the birth of a supernova in our lifetime? How will a stellar explosion challenge our understanding of the cosmos? Join us as we seek answers to these profound questions, journeying through the mysteries of space. This is not just an exploration of celestial phenomena. It's an invitation to marvel at the wonders of the universe, to question the nature of reality, and to dream of the possibilities that we lie waiting in the vastness of the cosmos. Welcome to a documentary experience that takes you beyond the boundaries of imagination, into the heart of the universe's greatest mysteries. Beyond the orbit of Mars, among millions of asteroids, the inconspicuous dwarf planet Ceres floats as if to upset the entire cosmic order. Despite its seemingly boring appearance, little Ceres challenged all of cosmology, standing on a par with other planets as the very first dwarf planet known to mankind. But that's not the only thing that has baffled scientists. In a sea of dim meteors, gray Ceres shines like a small star through mysterious bright footprints that may hide cold ocean depths where the heart of life is likely to beat. Today, we're traveling with you into the icy depths of the asteroid belt to meet the small planet Ceres, its ocean depths, and its mysterious radiance. So hop on, we'll be there soon. Ceres was first discovered in 1801 by astronomer Giuseppe Piazza. Initially, the scientists assumed that Ceres was a comet, but because of its slow and even motion, like a planet, he revised his calculations and continued observations. Even before the astronomers' research, well-known theorists such as Johannes Lambert had suggested there should be another planet in the gap, or asteroid belt, between Mars and Jupiter given its width. Piazza stopped working on his most significant discovery due to health problems, but his attempts to explore the distant and dark planet and calculate its orbit did not gather dust. Mathematician Friedrich Gauss, using the very limited data that Piazza managed to collect, was able to calculate the approximate orbit of Ceres. In particular, other astronomers such as William Herschel were even able to calculate the diameter, but it was far from reality. The researchers found that the size of the planet was only 160 miles, but in fact, according to modern observations, Ceres' diameter is 584 miles. Giuseppe Piazza considered the object he discovered to be a planet, and yet for 3 centuries Ceres was considered by the wider scientific community as an asteroid. Only in 2006 did the International Astronomical Union finally recognize Ceres as a dwarf planet along with Pluto. The discovery of Ceres could not but leave a mark on modern astronomy. Thanks to the small planet, scientists have deepened their knowledge of how the solar system was born and planets formed. For the first time, we were able to see the embryo of a planet, or planetesimal, so close. Ceres has expanded everything we know about cosmic bodies by its existence, actually forming a new type of planet as a dwarf planet. Due to the difficulties of studying a dim and seemingly dead planet, scientists have long considered it just a large body in the asteroid belt. Its mass is about 25% of all objects in the belt, but still, even dwarf Pluto is 14 times more massive than it. In particular, it seems that due to the gravitational effect of Jupiter, a small planet could not form completely. It is at the embryonic stage, without any opportunity to gain mass from the building asteroids that surround it. It takes 4.6 Earth years to complete a full orbit around the Sun, but its rotation on its axis is only 9 hours, making its day one of the shortest in the solar system. Interestingly, the axis tilt is not visible to the planet at all. It's only 4 degrees, so there's no possibility of feeling seasonal changes on Ceres. The night on the dwarf planet is also absolutely dark because it has no satellites, unlike most other planets, and no rings. Ceres is too small to hold them in its orbit. The planet's 3 times more distant from the Sun than Earth, so the annual average temperature there drops to negative 100 degrees Fahrenheit. Any heat that gets to the surface of Ceres is unlikely to stay there for long. It probably lacks an atmosphere and even a magnetosphere that would protect it from the radiation effects of solar wind. It doesn't seem that such a planet would be able to harbor any life. But pay close attention to the surface of Ceres. Despite its age of 4.5 billion years old, its surface has only a small bunch of craters and no deep impact basin. One could assume the planet could have survived a collision with another massive object that would have broken off a giant chunk of it. But the explanation for this strange phenomenon is different, but no less surprising. In 2015, the Dawn spacecraft went on an expedition to Ceres. The data collected by Dawn showed a rather unexpected result. Having made a complete map of the dwarf planet's surface, scientists concluded that its surface consists of a mixture of ice and minerals, such as clay and carbonates. Therefore, although it is similar to the Earth planet, its density is several times lower. Having studied the smooth surface of the craters, the very unusual bright spots on their bottom, and the furrow patterns across the surface, scientists came to the final conclusion that Ceres is geologically active. What makes its icy surface young again and again are cryovolcanoes. Ceres may consist of 25% water. This water pours out onto the planet's surface, filling deep craters with cryolava. Astronomers have noted that across the planet's surface you can see rocks, canyons with faults, which may also indicate geological activity, and several dozen cryovolcanoes, with the highest of them being the inactive Ahuna, which is 4 miles high. Ahuna, surprisingly, is a fairly young volcano, having formed about 1 billion years ago, which means that until recently, Ceres had enough heat to form such a geological object. A study by scientists led by paleontologist Maria Cristina de Sanctis found that some volcanoes may still be active, given the bright trail we'll return to later. The activity of these volcanoes is important, not only for the planet's surface, but also for its atmosphere. Due to eruptions or degassing, the atmosphere can be saturated and retain more and more heat. However, Ceres is not a simple case. Its gravity is not strong enough to maintain a permanently dense atmosphere. Instead, Ceres' atmosphere is variable, meaning that it sometimes appears and then disappears. This is all due to solar activity. When the sun heats the ice very strongly, it sublimates, forming a temporary exosphere, and that disappears in a few weeks. At present, scientists working at the European Southern Observatory's Very Large Telescope see no hints of atmospheric recovery shortly. The 57-mile Ocator crater has drawn another serious attention. It was formed 20 million years ago after a likely collision with a very massive object. After the impact, Ceres' crust cracked, releasing much water, which formed long furrows and patterns. The water also washed clay-forming minerals rich in magnesium and ammonium, known as phyllosilicates, to the surface, along with an unusual marine mineral called hydrogolite, and that was found only on Earth. That brings us to another interesting discovery. Ceres may be an oceanic world. Under the icy surface of a dwarf planet, there could be deep subsurface liquid ocean, but that was in the distant past. Now, most likely, the inner ocean is frozen, but not completely. Liquid, salty water deposits still exist beneath the surface. Their depth can reach an average of 25 miles, and it's likely that water ice with various gases, such as methane, can make Ceres' crust insulating, thus heating the water internally. Scientist Maria Cristina de Sanctis says that the ocean on Ceres had no reason to exist and should have been frozen by now. But Dawn's research has shown part of it could have survived under the surface. The temperature of these remnants of water can be as low as -22 Fahrenheit, and that's due to the large amount of salt and a mixture of other minerals to stay in a liquid state. According to Dr. Hannah Sizemore, Ceres cannot receive heat from, for example, tidal energy, from orbiting a more massive object like Saturn's moon, Enceladus, and thus keep the entire ocean inside liquid all the time. The impact that formed Ocator became the main driver of cryovolcanism on Ceres, bringing cold water from the ocean to the surface, leaving behind the same strange bright traces that allowed us to confirm the presence of water on the planet. So what are these mysterious marks? At the bottom of Ocator and other craters like Cerealia Facula, scientists have noticed large, shiny traces that reflect almost 50 to 60% of all the light that hits them. And the origin of these traces has been puzzling to researchers. At first, the bright spots were thought to be just ice plumes or traces of ammonia or methane, but now scientists are developing another theory. Likely the answer to the mystery of what all these bright spots hide is salt. After cryolava erupts from saltwater reservoirs, the substance gradually evaporates, leaving behind a salt crust containing magnesium sulfate, Epsom salt, and sodium carbonate. In total, the Dawn mission recorded more than 300 such bright areas. Interestingly, however, they all differ. The brightest spots are located at the bottom of craters and consist of salt-rich material mixed with water. Another group of bright salt deposits can be found in the form of streaks and patterns, diverged from the craters as a result of collisions with meteoric bodies. According to researcher Nathan Stein, over hundreds of millions of years, bright material has mixed with dark material to form the bulk of Ceres' surface. This indicates that billions of years ago, there were many more collisions with the dwarf planet and more than 1,000 bright spots. But why are some spots brighter than others? The process of creating such areas can also be quite specific and unique. For example, there's probably a reservoir of water under Ocator, so cryovolcanic activity increases its brightness more intensely. The Cerealia Facula crater with a slightly less bright spot could have formed in a more complex way. Cryolava could have moved slowly upward, creating a dome inside which material was boiling all the time until it settled as a mixture of ice and salt pieces on the surface. This whole process of forming bright patches of salt has not yet stopped. Paleontologist Maria de Sanctis has found evidence of traces of sodium chloride in Ocator, and after coming to the surface, the water component of this salt should have boiled off within 100 years, but the salt still remains moist. The bright spots again prove the fact of geological activity on Ceres, which is important for the most important process on every planet, the formation of life. As cold and inhospitable as Ceres may be, it meets many of the necessary criteria for the emergence of simple microorganisms and may already have life among its icy layers. Liquid water is the main environment in which life can arise, but of course, to form even an organism's embryo, various chemical elements are needed, the most important of which is carbon. Carbon is used to form the skeleton of living organisms and other crucial chemical compounds. Therefore, knowledge about the composition of the dwarf planet's surface will help answer the question of the possibility of life there. Thus, according to the data collected by Dawn, Ceres' surface contains a lot of silicate and iron rocks, but carbon also makes up a very significant proportion. About 20% of the surface mass consists of organic carbon, which is 5 times more than in carbonaceous chondrite meteorites on Earth. Moreover, the analyzed carbon is mostly mixed with water and clay. Such mixtures, when combined with oxygen and hydrogen, create a variety of organic compounds including sugars, alcohols, and fats. However, this is not the only chemical element important for the development of life that's available on the planet. Water itself already contains a whole range of compounds. Materials on the planet have undergone significant change over billions of years. For example, rocks, such as serpentine and carbonate minerals in the interior of Ceres, melted due to radioactive decay inside the planet, forming rocks similar to shale. The newly formed material probably formed pockets of salty liquid, filling the water with various substances, such as sodium, sulfur, methane, etc. Such a soup of building blocks could be a niche for life, according to geophysicist Mohit Daswani. But more than that, millions of years ago, when there were more collisions and thus the planet received more heat, simple microbial life could hypothetically exist. Therefore, primitive life could probably develop in water tanks right now. However, the problem is still the absence of an atmosphere for a long period of time that would prevent the surface from strong radiation. In particular, the exact amount of liquid water is not known to say for sure that life has a place to form, and in addition, the Dawn mission did not confirm the presence of large amounts of nutrients such as nitrogen or phosphorus, which are necessary for any life activity. Only future missions and soil samples can determine whether Ceres is habitable. In more than 10 years, NASA astronomers plan to send a new expedition to Ceres to collect a sample from the planet's surface. Researcher Dr. Julie Castillo-Roguez says the proximity and low gravity of the planet will allow them to return samples at a relatively low cost. The doctor is confident that there will be organic matter in Ceres salts, which gives us more hope that we can finally find out if we're alone, at least in the solar system. Ceres is an ideal natural laboratory that offers scientists many opportunities to explore the history of our solar system and the origin of life in difficult conditions. Such an intriguing object as the dwarf planet Ceres is of almost unprecedented importance in the study of planetary evolution, and the study of its geological features will allow us to model the entire cycle of planet formation. Future research may be crucial and a breakthrough for all of cosmology. Ceres could hypothetically become one of the first planets on which humanity will find new life. Perhaps this small and inconspicuous dwarf planet will also draw the attention of scientists to dozens of other similar icy oceanic worlds that also have many secrets. There is a hidden symphony in the vast expanse of space. Planets, moons, and black holes resonate with sounds we are only beginning to understand. On Earth, sound is part of our everyday life. But what happens when we go out into the cosmic vacuum where there's no air for sound to propagate? What we've discovered with modern instruments is a revelation. The thundering sonic booms of Jupiter's massive magnetic field, a powerful force that creates waves that travel millions of miles. The eerie radio waves of Saturn, a planet surrounded by rings, singing a haunting melody. Traveling with Voyager 1, we captured the very essence of the edge of our solar system, a frontier where human ears have never ventured, and immersing ourselves in a symphony of sounds organized by a supermassive black hole in the Perseus cluster. But what do these celestial bodies sound like? How can we hear them? And what do these sounds mean? In this audio odyssey, we'll explore the science behind these sounds. We'll learn what they say about our universe and their significance for our understanding of the cosmos. On Earth, sound is as natural as the air we breathe. It's the splash of waves, the rustle of leaves, the heartbeat of life itself. But what is sound? At its essence, sound is a vibration, a dance of molecules carried in a medium such as air or water. It's a wave, a rhythmic movement that reaches our ears and turns into melodies and sounds we recognize. From the gentle splash of a lake to the roaring thunder of a waterfall, sound paints the landscape of our world. It is science, the physics of waves and frequencies, but it's also art and a symphony of nature. But what happens when we leave the familiar embrace of the Earth? There's no air in the cosmic vacuum and no medium to transmit vibration. Is the cosmos really silent? An astronaut floating in the void would hear nothing, not even his own breathing. And this silence would be profound, absolute, a reminder of the vast emptiness that extends beyond our world. But space is not without sound. It is filled with radio waves, electromagnetic vibrations that echo across its vastness. How can we hear this cosmic echo? How do we translate the inaudible into something understandable to our ears? It's a challenge that's prompted scientists and engineers to create unusual instruments, radio telescopes that pick up the faintest signals, and space probes that listen to the vibrations of distant planets. Voyager's golden record, a message to the stars, carries the sounds of Earth. But beyond that, the Voyager probe also listens. The space probe is equipped with instruments that detect and record signals from the universe. These signals provide information about cosmic events and phenomena, allowing scientists to analyze and understand them. This process is a continuous exchange of data between our world and the cosmos. With the help of technology, we're turning cosmic vibrations into sonic sensations. We can hear the rings of Saturn, the magnetic field of Jupiter, and even the distant roar of a black hole. Take a look at Jupiter, the gas giant, the king of the planets that outshines all others in our solar system. A world of tumult and mystery, where the very fabric of nature resonates with power and majesty. At the heart of Jupiter's greatness is the magnetic field, a force so immense that it extends beyond Saturn's orbit. It's a magnetic conductor, orchestrating a symphony of waves and particles. Space probes such as Voyager and Juno, equipped with instruments to detect and analyze magnetic waves, have ventured closer to the giant. What they have found is a world filled with sonic booms, vibrations that resonate for millions of miles. These sonic booms are created by the interaction of charged particles with Jupiter's magnetic field. It's a dance of electrons and ions that result in waves powerful enough for our technology to detect. Compared to Earth's magnetic field, Jupiter's field is nearly 20,000 times more powerful than Earth's. It's a force that shapes the environment, influencing the behavior of the moons and even the solar wind. But what do these sonic booms sound like? How do we translate the magnetic vibrations into something our ears can perceive? Scientists have used technology to turn these magnetic waves into audible sounds. It's a roaring, thundering noise that reflects the turbulence and complexity of Jupiter's atmosphere. The sounds provide a glimpse of the gas giant's storms, including the famous Great Red Spot, a storm larger than the Earth that has raged for centuries. They reveal the dynamics of the atmosphere, the winds, the pressures, and the very essence of a world in constant motion. In its turbulent atmosphere also lurks an unexpected melody, a serenade that resonates with birdsong. Welcome to the cosmic symphony of Jupiter's chirping birds. The chirping of Jupiter's birds is not a sound you'd expect from the planet. This phenomenon, detected by the Voyager space probe, is a series of electromagnetic waves. These waves are the result of the interaction of charged particles with Jupiter's powerful magnetic field. They create oscillations, vibrations that, when translated into sound, resemble the chirping of birds. But what creates these unique sounds? What is the science behind the song? The answer lies in Jupiter's atmosphere, a turbulent world of storms, winds, and magnetic forces. The chirping of birds is created by charged particles, electrons, and ions that dance with Jupiter's magnetic field. It's a ballet of physics that results in a melody unlike any other. Space probes equipped with sensitive instruments detect these electromagnetic waves. They are then converted into sound, allowing us to hear this cosmic serenade, the chirping of birds that travels millions of kilometers. Understanding Jupiter's sonic booms and its bird chirps is more than just an auditory experience. It's the key to unlocking the secrets of the gas giant's atmosphere. It reveals the dynamics of the magnetic field, the behavior of charged particles, and the very essence of the world in constant motion beyond our reach. In the shadow of Jupiter, a world of ice and stone rotates silently. Ganymede, the largest satellite in our solar system, is a place of mystery and intrigue. But within its icy surface, a voice is heard, a whisper, telling the story of the cosmos. Welcome to the mystical whisper of Ganymede. This satellite has its magnetic field, a rare trait among moons, as we've already released a video about on this channel. And in that magnetic field lies its voice. The Juno space probe has detected magnetic vibrations that resonate in the icy shell of Ganymede. These vibrations, translated into sound, become whispers, soft mumblings that speak of Ganymede's hidden world. Ganymede's whispers may contain clues about its interior, a subterranean ocean that may contain life. They reveal the dynamics of the moon's magnetic field, its interaction with Jupiter's vast influence, and the secrets hidden in its icy embrace. Located in Jupiter's neighborhood is ringed Saturn, a planet that's captured the imagination of poets and scientists alike. Its beauty is undeniable, but the sounds it makes are a mystery that beckons explorers. Saturn isn't just a visual marvel, it's an acoustic mystery. The planet emits radio waves, a phenomenon first detected by the Voyager spacecraft. These waves are not random, they represent a coded message from deep within Saturn's atmosphere. What causes these radio waves? Some are the result of lightning strikes in Saturn's turbulent atmosphere, others are more mysterious and related to the planet's magnetic field and the dance of charged particles. The Cassini spacecraft spent more than a decade studying Saturn, and its instruments provided a wealth of data. Radio waves have been converted into sound, an eerie, frightening noise that resonates within the unknown. Unlike Earth, where radio waves are largely man-made, Saturn's radio emissions are a natural phenomenon. It provides insight into the planet's weather, its magnetic environment, and the complex interactions that shape this gas giant. But the mystery of Saturn's sounds doesn't end with its radio waves. The rings themselves, those very bands of ice and dust, contribute to the planet's soundscape. The rings are not silent, they vibrate, they resonate. Cassini's recordings of the rings capture the very gravity-driven melody. Particles inside the rings collide and interact, creating waves that can be detected by sensitive instruments. The sounds of Saturn's rings are key to understanding the structure, composition, and dynamics of the rings. They tell a story of formation and evolution, a story that echoes the history of our solar system. So let's get back to our pioneering probe. In 1977, the Voyager 1 spacecraft embarked on a journey that changed our understanding of space. A distant messenger and a discoverer, Voyager 1's Odyssey is a testament to human curiosity and ingenuity. The journey of Voyager 1 has been a grand voyage of discovery through our solar system. From the thunderclouds of Jupiter to the enigmatic rings of Saturn, it was a voyage of discovery that expanded our horizons. The images sent back by Voyager 1 were a revelation. The swirling storms of Jupiter, the icy beauty of Saturn's rings, the blue mystery of Uranus, and the distant majesty of Neptune. Each encounter was a milestone of discovery. However, the journey of the spacecraft did not end at the planets. It continued, going deeper into the unknown, crossing the border of our solar system and entering interstellar space. Mankind's first step into the cosmic wilderness. At the edge of our solar system is the heliopause, the boundary where the solar wind meets interstellar medium. Voyager 1 has crossed this threshold and in doing so has picked up sounds and vibrations that resonate with the fabric of space. These sounds are inaudible to a human ear, but through technology they've been transformed into something we can hear. The hum, the murmur, the distant echo of the cosmic sea. But what do these sounds mean? These vibrations are a key to understanding the environment beyond our solar system, a glimpse of the interstellar medium, and a link to the universe as a whole. They reveal the properties of plasma, charged particles, and magnetic fields that permeate the cosmos. They shed light on processes such as star formation, the behavior of supernovae, and cosmic rays. They provide a glimpse into the fundamental forces that shape the universe. The data collected by Voyager 1 serves as a tool for future exploration. It informs us about interstellar space, guiding future missions and enhancing our ability to navigate the cosmic sea. The sounds captured by Voyager 1 are truly a scientific treasure trove. They signify that we've stepped outside our home and listened to the whispers of space. We already realize that sound cannot exist in space because of the vacuum, which is a common misconception. This is further confirmed by the cluster of galaxies, which provide a medium for the propagation of sound waves. 250 million light-years away is the Perseus Cluster, a collection of galaxies bound by gravity. It's home to a supermassive black hole that orchestrates a cosmic symphony. The black hole in the Perseus Cluster is more than just a dark void. It shapes the environment, influencing the behavior of galaxies, stars, and even the fabric of the universe itself. Around the black hole's event horizon, matter twists into an accretion disk, a whirlpool of gas and dust that emits X-rays and radio waves. These waves cover everything in the neighborhood up to 30,000 light-years away and pulsate the ultra-hot gases that make up the galactic cluster. The waves have been detected by instruments like the Laser Interferometer Gravitational Wave Observatory, or LIGO, which can be converted into sound. They are a symphony of gravity and melody reflecting the dance of mass and space-time. Scientists have resynthesized these pressure waves into sound waves that humans can hear. By increasing the frequency of the sound wave by 144 quadrillion times, the Perseus sound becomes audible. Sounding black holes is a pioneering attempt to hear the universe. By matching electromagnetic radiation with the audible tones, scientists have created sonic representations of cosmic phenomena. The brightest and loudest parts represent the black hole itself, with the sound fluctuating depending on the jets of the radiation emitted. Contrary to the belief that sound cannot exist in space, clusters of galaxies provide a medium for sound waves. In the Perseus cluster, sound waves were made audible by scaling them upward by 57 and 58 octaves, allowing listeners to hear waves emitted in different directions. Sounding black holes such as M87 in the Perseus galaxy cluster provide insight into black hole dynamics and charged particle behavior. This ongoing project, led by NASA's Chandra X-ray Observatory and NASA's Universe of Learning program, offers a unique way to explore the symphony of the cosmos. From the unique auditory phenomena of Jupiter and Saturn to the distant messages of Voyager at the end of our system and beyond, this journey resonates with the essence of being. But it's not finished. It's only beginning. The universe is vast and its mysteries endless. There are more sounds to hear, more mysteries to explore, and more questions to ponder. Stay curious, keep exploring, and never forget the inspiring melody of the universe. The deeper we dive into space, the more incomprehensible and hostile it becomes to live. Sometimes even hypothetical space monsters are not as frightening as ordinary planets. A Neptune-like gas giant will leave no trace of humans with its constant rain of glass, while two zombie planets orbit a long-dead star in the constellation Virgo, suffering from radiation every day. Today we're going to take you on a short journey to planets that you would hardly want to visit in reality. The first planet in line is the blue gas giant HD 189733b. It's slightly larger than Jupiter, but unlike the largest planet in the solar system, HD 189733b is only 2,905,798 miles away from its star. For comparison, the distance between Jupiter and the Sun is almost 166 times greater. Therefore, one orbital period of HD 189733b around its star takes only 2.2 days with an orbital speed of 134,000 miles per hour. The star around which the gas giant is moving is a K-type star or orange dwarf. Such stars have lower temperature than, for example, G-type dwarfs like our Sun, but they have a longer lifespan. These factors make these stars very promising for the development of life on planets in their systems, but the planet we're telling you about is definitely inhospitable to any life forms we know. HD 189733b is too close to its star. According to various sources, the giant's temperature reaches almost 2,000 degrees Fahrenheit, so it belongs to the class of hot Jupiters. In particular, it can be turned only one side to the star, but according to the Spitzer telescope, despite this, its surface still has a fairly high temperature around the perimeter. But that's not the only reason why HD 189733b is a life-threatening planet. I wonder why this planet is completely blue. Another gas giant, Neptune, as far as you know, has the same color because of its dense methane clouds. However, although there are traces of methane on HD 189733b, it's too hot for the gas to condense into clouds. In particular, there's no water there, only water vapor. So why does the gas giant have a similar color? This blue color of the planet is probably due to its strange atmosphere, which has reflective silicate clouds that form droplets of glass. On HD 189733b, it rains small glass particles, moreover along the horizontal. However, remember the planet's rotation speed. Because of this, its winds can reach almost 6,000 miles per hour. Superfast storms on HD 189733b with glass impurities could cause fatal harm to humans and very serious damage to other matter.
So the weather on this gas giant is dangerous, to put it mildly. In addition to glass storms and high temperature, HD 189733b is also very strongly irradiated by its star. The planet loses 100 to 600 million kilograms of atmosphere per second. Therefore, it's unlikely that anything would be able to survive on this deadly planet from all sides. You've probably seen images of hell before, a hot and creepy place filled with lava and covered in black soot. The next two planets, 55 Cancri E and K2 141b, can confidently claim to be real hell worlds with oceans of lava on their surfaces. 55 Cancri E is a rocky planet almost 8 times the size of Earth. It orbits at a distance of only 1,394,337 miles around a calm and rather cold red dwarf located 41 light-years from the Sun. It is the closest planet in the system. In addition to it, there are 4 other confirmed planets. All of them are gas giants, which are also very close to their central star, except for the last one, 55 Cancri D. A year on 55 Cancri E lasts only 18 hours, and only one side of it is likely to be irradiated. Thus, the temperature of its side facing the star can reach an average of 4,200 degrees Fahrenheit, and the unlit side averages from 2,400 degrees Fahrenheit to 2,600 degrees Fahrenheit. However, Alexis Brandiker, a researcher at Stockholm University, has noticed that the hottest spot is moving and the temperature around it is varying. He concluded that the planet may be in resonance with its star, which means it has a day and night cycle. However, the ultra-high temperature of the illuminated side indicates that this part of the planet may be molten and thus completely covered with a layer of lava. It is not known for certain whether the alleged night side is covered with lava. According to astronomer Renew Hugh, the entire plant should be covered with lava. Moreover, 55 Cancri E most likely has a dense atmosphere that can hide layers of lava. It consists mostly of the same elements as Earth's, mostly hydrogen, helium, as well as nitrogen and oxygen. But no traces of water vapor have been found there. So if this planet can have an atmosphere and still be in resonance with it, then it can cool down. But then this hellish world becomes even more dangerous. If the silicate surface heats up and evaporates during the day, then the vapor would cool down overnight and, like on HD 189733b, would create some precipitation, namely lava drops. Add to this the very fast movement of the planet around the star, and we get the likely hot storm with lava rain. Finally, such proximity to the star can cause volcanic activity on the planet, which can also increase the planet's temperature by blocking heat emissions. K2 141b is also a rocky planet that orbits the orange dwarf at a distance of 202 light-years. It's almost 5 times larger than the Earth and also has a density of 1.5 times more. But it moves at an even smaller distance from the star than 55 Cancri E, 694,379 miles. Therefore, 1 year on this planet lasts only 7 hours, making its orbital period one of the shortest known at the moment. The hellish winds can reach speeds of 5,000 miles per hour there. The planet is most likely blocked by tides. Its illuminated side can have a temperature of 5,430 degrees Fahrenheit, while at night the temperature drops to negative 328 degrees Fahrenheit. Likewise, the daytime side is completely covered by lava ponds at depths of more than 62 miles. Moreover, like our Earth's oceans, K2 141b has a similar magma cycle. The silicate rocks vaporize and fly at supersonic speeds to the cooled side, where they condense, and return to the hot side and fall out pebbles down, where they evaporate again, forming a thin layer of atmosphere and keeping the lava in balance. This is very similar to the weather on the previous planet, but because K2-141b is blocked, its precipitation has time to cool and therefore falls as rocks rather than lava. However, some studies indicate that the flow of minerals back to the illuminated side may be too slow, which could theoretically create an overload on one side and change the planet's rotation on its axis. Thus, the atmosphere of K2-141b consists of solid elements: sodium, sodium oxide, or silicon dioxide, meaning it has the same composition as the surface. Our Earth probably looked like this at the beginning of its formation, but it's highly doubtful that these two planets will ever be able to give any life a chance to develop. However, 55 Cancri E and K2-141b both pale in comparison to the theoretical Kepler 70b, a rocky planet that's hotter than the Sun itself. Kepler 70b, or KOI 55b, is probably 4,200 light-years away and orbits an incredibly hot dying star with a temperature of 49,452 degrees Fahrenheit. Kepler 70b is almost half the size of the Earth, but its density is similar to that of the Earth. According to the study of astrophysicist Stéphane Charbonnet, this planet may be only 557,734 miles away from the star. Therefore, the planet's surface could be around 12,000 degrees Fahrenheit. It's impossible to say exactly what the planet might look like because of the difficulty in studying it. But only part of the fried core may likely be visible from under that destroyed surface. It could have been a gas giant before, but it lost its shell. There's also another planet in this system, KOI 55c, which is probably also rocky. They may be in a 3-to-2 orbital resonance, which could explain why they probably still exist. However, this is not the strangest and scariest thing that's happened to this planet. As the central star is slowly dying, it's already past the red giant stage, the stage of star death when the thermonuclear fusion of hydrogen in the envelope begins due to the end of hydrogen reserves in the core. During this phase, the star begins to grow and absorb nearby planets. And since KOI 55b probably continues to move around the star, it has most likely spent some time inside its dying star and survived. When the planet, hypothetically a gas giant at the time, was inside, it could have completely lost its gas and liquid envelope, which is why that it has that scary half-dead appearance. In addition, it may be evaporating due to the influence of its star, so maybe the planet doesn't have much time left. So far, the existence of both planets has not been confirmed, and the signals from this system received by the Kepler telescope are interpreted differently. Proximity to one star is rarely favorable for the planet itself or possible life there. Another planet, TOI 849b, like the hypothetical KOI 55b, has only one burnt core left due to the influence of its host star. TOI 849b was probably a large gas giant, the size of half of Saturn, although it's possible that by the time the gas envelope was destroyed, it could have had the mass of Jupiter. However, it's also believed that it could have been a failed giant that failed to gain enough material during the protoplanetary disk phase. It orbits a Sun-like star at a small distance of 1,485,433 miles, so its temperature reaches about 2,800 degrees Fahrenheit. Because of its close proximity to its star, the gas giant has no trace of an atmosphere. In particular, even as a very dense, heavy, and giant exoplanet, it has very little hydrogen and helium. Although, this is really strange. If TOI 849b is so massive, then its gravitational forces should be able to hold on to a giant gas shell. However, according to research by scientists from the University of Geneva, even if this planet had formed farther from the star or indeed was the size of Jupiter, it would still have lost all its gas due to too much radiation in 50 million years. Now, such planets that have lost their envelope are called chthonic planets, meaning they are connected to the underworld. TOI 849b actually resembles an empty, hellish wasteland that could have been quite different in the past. So you've heard about half-dead planets that actually survive in incredibly difficult conditions. However, some planets could have been destroyed a long time ago, but eventually they came back to life again. One of these amazing planets is PSR B1257 plus 12c, a planet orbiting a dead star. PSR B1257 plus 12c, also known as Poltergeist, is located 2,300 light-years away in the constellation Virgo. It's a cold and rocky planet slightly larger than Earth that orbits its star in 66 days. In addition to PSR B1257 plus 12c, there are two other rocky planets in this system. PSR B1257 plus 12b, known as Draga, with an orbital period of 25 days, and PSR B1257 plus 12d, Phobeater, with a period of 98 days. However, their star is already at the final stage of its life. In the form of a neutron star, this means that it should have already exploded into a supernova and destroyed everything nearby, including massive planets. However, these planets continue to exist, which is hardly possible. Scientists believe that a massive protoplanetary disk may form around the pulsar from the remnants of the supernova, and in particular by capturing part of the nearest cosmic body, such as another star. The material that could remain after the evaporation of the planets, if they existed, would hardly be enough to restore them. So, the presence of a companion star explains the massiveness of the newly formed planets. In particular, there is another theory that explains the formation of planets by combining two white dwarfs. The less massive dwarf could collapse due to the impact of a larger star and then absorb the residual material until it reaches a huge mass, which would lead to the collapse of the core and the formation of a pulsar. Then, the disk remaining after all these processes could be sufficient for the formation of planets. All planets can experience strong radiation exposure, although it's possible that due to the distance of the planets, it would not be too great. So far, no systems similar to PSR B1257 plus 12 have been found, but the discovery of pulsar planets has really struck researchers as paradoxical. And finally, 750 light-years from our Sun is an amazing planet of endless night. However, it's not just a planet with one side blocked by the tides. You won't be able to see anything at all on TRES-2b, even if you have a flashlight. TRES-2b is a gas giant larger than Jupiter. It orbits very close to its sun-like star, so it's classified as a hot Jupiter. However, unlike all the gas giants that scientists have come across, this one is definitely one of the strangest and most interesting. TRES-2b is completely black. Its surface reflects light worse than coal or black acrylic paint, meaning it absorbs more than 99% of the incident light. However, since it is a very hot planet, it's likely to be possible to see a red glow from its interior. However, what causes this unusual color of this gas giant? It's impossible to say for sure what the cause is because of the vast distance, but astronomer David M. Kipping suggests that one reason for the lack of reflective clouds of ammonia, as on Jupiter due to the high temperature of about 2,930 degrees Fahrenheit. Instead, its atmosphere likely contains light-absorbing chemicals like sodium and potassium that evaporate. Still, this is not enough to explain the planet's deep black color. So if you were to find yourself on TRES-2b, in addition to the endless darkness through which you would hardly be able to see the stars, you'd also be exposed to hot, supersonic winds. It just doesn't sound very safe. Space beyond Earth continues to fascinate us, even if some planets make us scared. After all, not all planets can be considered suitable for life. Some of them may be a direct threat to any living organisms. Nevertheless, even the seemingly dangerous planets are worth studying to add to our knowledge, even to learn about the history of our own planet's formation. No matter how scary space may be, its exploration is the key to our further development.
Imagine a celestial object unlike anything we've ever seen, hurling through the vast void of space at 3 times the speed of the average comet in the solar system. This is not a figment of science fiction, but a mysterious visitor entering our solar system in 2017. This mysterious object is unique in that it's the first interstellar object ever discovered in our solar system, in honor of which it was named Oumuamua in Hawaiian, meaning a messenger from afar who arrived first. In a short time, it's baffled astronomers and spawned theories ranging from "it's just an asteroid" to alien spacecraft. Flying through our cosmic neighborhood, Oumuamua was 15 million miles from Earth, about 62 times the distance from Earth to the Moon. But what baffled scientists was its speed. As it revolved around the Sun, its rate increased, which contradicts the laws of celestial mechanics. Could it be propelled by some unknown form of cosmic radiation? Or is it a comet emitting gases in a way we've never observed before? In a universe governed by law and equation, Oumuamua is an unsolved equation, a cosmic enigma in the shape of a rock about 650 feet long. On October 19, 2017, in the quiet of space, far from the bustling activity of our blue planet, a telescope in Hawaii picked up a faint flicker. This was no ordinary celestial body, it was Oumuamua, the first known interstellar object to visit our solar system. The Pan-STARRS 1 telescope, perched atop the dormant Haleakala volcano, captured something unusual. The very name Oumuamua, in which Hawaiian means a messenger from afar arriving first, reflects the significance of this discovery. Unlike asteroids and comets born under the gravity of our Sun, Oumuamua was a wanderer from deep in interstellar space. Its trajectory indicated that it was not bound by the Sun's gravity, making it a transient visitor to our system. What sets Oumuamua apart is not only its origin, but also its special characteristics. Its elongated cigar shape, its rapid rotation, they don't fit the norms of typical objects in the solar system. The scientific community is buzzing with theories and debates about the nature of Oumuamua. Is it a comet without a tail, asteroid with an unusual rotation, or something completely different? These questions have sparked rigorous scientific research that's led to a variety of hypotheses. From it being a fragment of a larger celestial body to even more speculative ideas such as it being an alien probe. The discovery of Oumuamua is a milestone in astronomy, similar to when people first looked through a telescope and realized that the Earth is not the center of the universe. It sheds light on the formation of the solar system and reminds us that our solar system is only a tiny part of a vast, unexplored frontier. As Oumuamua moves farther away, becoming a faint speck in the cosmic sea, the need to study it grows. Hopefully, in the future, more advanced telescopes will capture more information about these interstellar messengers, offering new clues about the composition and history of the universe. The mystery of Oumuamua's true nature has puzzled astronomers since its discovery. Originally classified as a comet, it had none of the typical cometary features, such as a luminous coma or tail. It was for this reason that it was reclassified as an asteroid due to its lack of a visible coma. However, it is not just any asteroid. It is an elongated, cigar-shaped object, unlike any asteroid we've seen before. Its unique shape has led to various speculations, including the possibility that it's an alien spacecraft. Scientific papers describe the physical characteristics of Oumuamua in more detail. They mention the object is tumbling rather than spinning, which is unusual for both asteroids and comets. This tumbling motion could be the result of a collision with another planet, but this statement is purely speculative at this point. The trajectory of Oumuamua presents another intrigue. It entered our solar system at an unusually high speed and traveled on a hyperbolic trajectory, which in turn means it will never return. Most objects captured by a star's gravity go into an elliptical orbit, but not Oumuamua. According to the scientists' assumption, its trajectory was influenced by non-gravitational forces, which can be explained by the release of materials due to rapid vaporization. Again, however, no such gas releases were visually observed, which further adds to the mystery. The lack of a visible coma and the object's high speed have led to various theories, some scientists suggesting it could be a fragment of a larger object that crashed. Others believe it could be a new class of object rather than a comet or an asteroid. Some even discuss the possibility that Oumuamua is a solar sail driven by radiation pressure. It's also believed that the object's high speed could make it a messenger from another star system, perhaps ejected by a planetary system forming around a young star. This could make Oumuamua one of the first observed interstellar objects, a relic from another part of the galaxy. The story of Oumuamua is a space detective story where each clue only deepens the mystery. Its elongated shape is unlike anything we've seen in the solar system. Could this unique form factor offer benefits for interstellar travel, such as reduced drag or increased stability? Or is it the result of some catastrophic event that we cannot yet fathom? Its trajectory adds another layer to the mystery. The absence of a visible coma and tail rules out the possibility that outgassing influenced its path. So what non-gravitational forces are at work here? Could it be affected by dark matter or some other unknown cosmic phenomenon? The theories surrounding Oumuamua range from the plausible to the fantastic. Could Oumuamua be a harbinger, a messenger from another star system? The possibility that it's a solar sail is particularly intriguing, and if proven, it could revolutionize our understanding of space travel, opening up the possibility of radiation-propelled voyages between stars. So when it comes to investigating celestial objects like Oumuamua, astronomers rely on a variety of tools. The investigation into the nature of Oumuamua was led by a team of researchers that included Jennifer Bergner, a chemist at the University of California, Berkeley. Bergner and her colleague Daryl Seligman, an astronomer at Cornell University, were at the forefront of unraveling the object's mysteries. Their work, published in the journal Nature, is considered the most convincing model of Oumuamua, and that's according to Marco Michelli, an astronomer at the European Space Agency. The team's observations were supported by NASA's Hubble and Spitzer telescopes, which found that Oumuamua had a strangely elongated cigar-like shape and accelerated slightly as it left the solar system. This acceleration is commonly seen in comets when they're repelled by the material they emit. However, Oumuamua showed no such ejection or any visible coma of dust and gas, which we would expect of a comet. The team used modeling to show that Oumuamua could have originated as a normal, water-rich comet orbiting a nearby star before being ejected outside the system. High-energy cosmic rays could have converted up to 30% of the comet's water ice into hydrogen, which could have been trapped in Oumuamua's ice as it traveled through interstellar space. As it approached the Sun, the trapped hydrogen should have been released, giving the object the increase in velocity. According to Seligman, the team's theory explains every strange aspect of Oumuamua. It suggests that Oumuamua was indeed a comet, albeit an unusual one. The lack of a visible coma or tail can be explained by the fact that molecular hydrogen is much less massive than the materials ejected by typical comets, and therefore does not entrain much dust. While Bergner and Seligman's theory is convincing, it's worth noting that not everyone in the scientific community is convinced. Karen Meach, an astronomer at the University of Hawaii at Manoa, still believes that the conventional model of a comet could have occurred. She suggests that Oumuamua could simply have a small amount of dust, which would also explain the lack of a visible coma or tail. Another theory, the idea that Oumuamua could be an alien probe, has captured the public's imagination. Its elongated cigar shape and unusual trajectory led to speculation that it could be an artificial object. This theory gained traction when Avi Loeb, an astrophysicist at Harvard, suggested that Oumuamua could be a thin, flat, almost rectangular piece of material that could be a probe sent by an advanced civilization. Loeb's theory was widely reported in the media, fueling speculation. Although the alien probe theory made headlines, it's not stood up to scientific criticism. First, if Oumuamua was a probe, it would likely have emitted some form of radiation or signals that have not been detected. Secondly, its tumbling motion is not consistent with what one would expect from a probe designed to move steadily or collect data. Moreover, the object's trajectory can be explained by natural phenomena, as discussed in the previous chapter. The theory proposed by Jennifer Bergner and Daryl Seligman, which suggests that Oumuamua is a hydrogen-rich comet, explains its unique characteristics and does not require extraterrestrial intervention. The idea that Oumuamua could be an alien probe reflects our collective fascination with the unknown and the possibility of intelligent life beyond Earth. However, it also serves as a cautionary tale about the importance of rigorous scientific research. Speculative theories, while interesting, can divert attention away from a more plausible explanation. Although Oumuamua's unique characteristics have puzzled astronomers, the most plausible explanation is that it is an exotic type of comet or asteroid. Its long journey through interstellar space probably altered its composition, forming a crust that held most of the frozen gas inside. This theory explains the unique characteristics and is supported by observations by NASA's Spitzer Space Telescope. The discovery of Oumuamua has important implications for our understanding of interstellar objects. It suggests that trillions of such objects may be passing through our solar system, and we've only just begun to detect them. The Large Synoptic Survey Telescope in Chile is expected to receive its first engineering camera light in December 2023. Full-fledged survey operations are scheduled to begin in October 2024 due to schedule delays associated with COVID-19. Once operational, LSST will potentially be able to detect more objects, such as Oumuamua. It is planned that LSST data will be fully publicly available in 2 years, opening up new possibilities for understanding these enigmatic interstellar visitors. Beyond telescopes, advances in propulsion technology and data analysis may allow us to intercept and study these objects more closely. Imagine a future where we could send a probe to rendezvous with an interstellar object, collect samples, and send back data in real time. Construction of the European Comet Interceptor mission was recently approved.
The European Comet Interceptor mission represents a significant leap in our ability to study interstellar objects like Oumuamua. Unlike previous missions that were designed to study objects inside our solar system, the Comet Interceptor is specifically designed to collect data on objects from outside it. The mission is led by ESA with support from the Japanese space agency JAXA. The project aims to scrutinize a comet that has spent little time in the inner solar system and may be visiting for the first time. The mission will build on the successes of Rosetta and Giotto, previous ESA missions that visited short-period comets. The spacecraft will consist of a main unit and 2 probes designed to observe the comet from different angles and create a 3-dimensional profile of its yet-to-be-discovered target. The mission is expected to be launched in 2029 and will travel to space with ESA's Ariel exoplanet mission. Once in space, the Comet Interceptor will wait for a suitable target at the point of the L2 Lagrangian, a location 1.5 million kilometers behind Earth when viewed from the Sun, waiting for the next interstellar objects to pass right through our solar system. Once such an object is detected, the spacecraft will adjust its trajectory to make a close flyby, capturing high-resolution images and collecting data on its composition, structure, and even origin. The discovery of Oumuamua opened a new chapter in astronomy. How common are such hydrogen-rich comets in the universe? Could there be other interstellar objects with a different composition and behavior? And most importantly, how can we prepare to better study these objects in the future? This has served as a harbinger of future discoveries, encouraging us to prepare for new interstellar visitors that may be just as mysterious, if not more so. In the vast expanse of space, among the countless stars twinkling in the night sky, celestial events of unimaginable scale and power take place. Events that eclipse entire galaxies and reverberate throughout the universe. Today we will delve into one such event, the stellar cataclysm known as a supernova. From ancient civilizations that saw these events as omens to modern astronomers studying them to understand the universe, supernovae have always fascinated us. Recently, the star Betelgeuse has dimmed dramatically, leading some scientists to speculate that it may soon turn into a supernova. If it does, it would be the brightest supernova observed from Earth in more than 400 years. Today we're going on a journey to understand these stellar cataclysms and their impact on our planet and their story of our place in the cosmos. We dive into the fascinating world of supernovae. In the great theater of the cosmos, the stars are the protagonist. They are born, they live, and they die. But some stars give such a spectacular performance in their final act that it outshines entire galaxies. They are supernovae, the catastrophic death of stars. But what is a supernova? Simply put, a supernova is a powerful and bright stellar explosion. It occurs during the last stages of a star's life, when the nuclear fusion in its core can no longer support the outer layers of the star. This causes the nucleus to collapse under its own gravity, leading to a violent explosion that can briefly obscure the entire galaxy. The energy released by a supernova is so enormous, it's equivalent to the energy that our sun would radiate over its entire 10 billion year lifetime. Supernovae are not just fascinating cosmic phenomena. They play a crucial role in shaping the universe. They are responsible for the distribution of elements throughout space, elements necessary for the formation of planets and life as we know it. In fact, it's believed that most elements heavier than iron, including gold and platinum, were formed by supernova explosions. So the gold in your jewelry, the iron in your blood, the calcium in your bones, all of these were once part of a star that was cut short by a spectacular explosion. Long before telescopes, space probes, and modern astronomy, ancient civilizations were already observing the stars. They noticed patterns, mapped constellations, and recorded celestial events. Among these events were the sudden appearances of new stars, which we now know as supernovae. One of the earliest recorded observations of a supernova was made by Chinese astronomers in 185 AD. They described a guest star that appeared in the sky, was visible in daylight for several weeks, and disappeared after about 8 months. We now know it was a supernova, and its remnants, known as RCW 86, have been observed with modern telescopes. Another famous historical supernova is SN 1054, Crab Nebula, discovered by Chinese and Arab astronomers in 1054. This guest star was about 4 times brighter than Venus and was visible during the day for 23 days. The remnants of this supernova are what we now call the Crab Nebula. The ancient observations of supernovae had a profound effect on the way these civilizations understood the cosmos. They challenged the idea of an unchanging universe, an idea prevalent in many cultures. They were also used for astrological predictions and were often seen as omens. Today we continue to study supernovae not as omens but as opportunity to learn more about the life cycle of stars, the creation of the elements, and the history of our universe. Although our understanding of the cosmos has grown, these stellar explosions continue to fascinate us with their power and mystery. Recently, the star Betelgeuse in the constellation Orion has attracted the attention of astronomers. Betelgeuse, a red supergiant, is nearing the end of its life, and at the end of 2019, it began to dim dramatically, leading some to speculate it may soon become a supernova. However, it has since returned to its normal brightness. The most widely accepted explanation for this event is that the star emitted a large dust cloud, which obscured some of its light and made it dimmer from our perspective on Earth. When the dust cloud dispersed, Betelgeuse's brightness returned to normal. This serves to remind us the universe is not a static place, but a place where stars are born, live, and die in spectacular ways. Every star in the night sky has a story to tell, a story that begins long before we see its light. The life cycle of a star is a journey of transformation, from a mere cloud of gas and dust to a beacon of light that can outshine a galaxy. The journey begins in nebula, a huge cloud of gas and dust. Inside these cosmic nurseries, pockets of gas and dust begin to collapse under their own gravity. When they collapse, they heat up and form a protostar. Over millions of years, the protostar continues to gather mass from the surrounding nebula. As it grows, the pressure and temperatures in its core increase. When the core temperature reaches about 27 million degrees Fahrenheit, nuclear fusion begins. The protostar is now a main sequence star, just like our Sun. A star can remain on the main sequence burning hydrogen in its core for billions of years, but eventually the hydrogen fuel runs out. What happens next depends on the star's mass. In stars the size of our Sun, the core shrinks and heats up, causing the outer layer to expand. The star becomes a red giant. Eventually, the core collapses and the outer layers are ejected, forming a planetary nebula. This leaves a white dwarf. But as we travel through space, we find that not all stars meet their end in the same way. A star can also go supernova. Its type will largely be determined by the mass and composition of the original star, while also having its own unique characteristics. For example, spectral analysis of Type 1 supernovae lack hydrogen lines. The most famous subtype, Type Ia, occurs in a binary stellar system. A white dwarf, the dense remnant of a star similar to our Sun, sucks matter from its companion star. Once the white dwarf reaches a critical mass, it undergoes a thermonuclear explosion, resulting in a supernova. On the other hand, type IB and IC supernovae are thought to result from the collapse of the cores of massive stars that have lost their outer layers of hydrogen, and for type IC, helium. Now, let's focus on one of the most common types of supernovae we observe, type 2. These supernovae originate from the massive stars much larger than our own Sun. Stars with at least 8 times the mass of the Sun can undergo this dramatic transformation. Throughout their lives, these massive stars are in a constant battle between gravity pulling inward and the force of fusion pushing outward. When a star exhausts its nuclear fuel, gravity wins the battle. The core of the star collapses under its enormous gravity. This collapse of the nucleus occurs incredibly quickly, in just a fraction of a second, and leads to a powerful explosion, a supernova. The outer layers of the star explode in a spectacular spectacle, outshining the entire galaxy for a short time. What's left of the star may form a dense neutron star, or if it was massive enough, a black hole. But the legacy of the star lives on. The explosion disperses the elements formed during the life of the star into space, seeding the cosmos with building blocks for new stars, planets, and even life. When a star goes supernova, it's not just a spectacle of light. It's one of the most energetic events in the universe. The amount of energy released in a supernova explosion is so enormous, it's equivalent to the energy the Sun would radiate over its entire 10 billion year lifetime. But where does all this energy go? Most of it is carried away by neutrinos. These tiny, nearly massless particles are produced in huge quantity during a supernova. They travel at nearly the speed of light, taking about 99% of the explosion's energy with them. The rest of the energy is released as light and other forms of electromagnetic radiation. This includes gamma rays, the most energetic form of light, and X-rays, which are less energetic but still much more powerful than the light we see. The visible light from a supernova is so bright that it can briefly obscure the entire galaxy. This light can be seen at great distances, making supernovae important cosmic beacons for astronomers. Although supernovae are interesting to observe, they can also pose a potential danger. The enormous energy and radiation released in a supernova explosion can have significant consequences, especially if the supernova is close enough to Earth. One of the main causes of concern is the impact on our planet's ozone layer. The ozone layer acts like the Earth's sunscreen, protecting life from the sun's harmful ultraviolet radiation. But an intense gamma-ray burst from a nearby supernova could destroy the ozone layer, increasing the amount of UV radiation that reaches the Earth's surface. This increased UV radiation can have harmful effects on the Earth's biosphere. It can lead to higher rates of skin cancer in humans and other animals, and disrupt photosynthesis in plants, potentially affecting the entire ecosystem. In addition to gamma rays, the supernova also emits a stream of high-energy cosmic rays. These particles can further damage the ozone layer as well as create streams of secondary particles in the Earth's atmosphere that would increase the radiation dose. In our study of the dangers posed by supernovae, there's another interesting aspect to consider: gravitational waves. These are ripples in the fabric of space-time caused by some of the most violent and energetic processes in the universe. Albert Einstein predicted the existence of gravitational waves in 1916 in his general theory of relativity. Einstein's mathematics showed that the massive accelerating objects like a neutron star or a black hole orbiting each other would collapse space-time in such a way that distorted space waves would emanate from the source. And supernovae, with their incredible mass and explosive energy, are the first candidates to create such waves. When a massive star collapses and explodes, the asymmetry of the explosion can potentially create gravitational waves rippling through space. These waves will be incredibly weak by the time they reach us, and will pose no danger to Earth, but they give us a new way to study the universe. Scientists have already begun to detect these waves with incredibly sensitive instruments, ushering in a new era of gravitational wave astronomy. Fortunately, the probability of a supernova exploding close enough to affect Earth is quite small, but understanding these potential dangers is crucial. It's a reminder of our connection to the cosmos and how events occurring light years away can have consequences right here on our home planet. As we've seen, supernova explosions are powerful events that can have far-reaching consequences. But did you ever guess that supernovae may have played a role in shaping Earth's history? Scientists have found evidence of past supernovae in the form of iron-60, a radioactive isotope in ancient geological layers and cores of Antarctic ice. Iron-60 is not naturally produced on Earth, but created by supernovae, suggesting that our planet was dotted with the remnants of these stellar explosions. One notable event is the Pleistocene supernova, which erupted about 2.7 million years ago. Some scientists speculate that this supernova may have affected Earth's climate during the Ice Age, perhaps even contributing to a period of cooling. There's also a theory that supernovae may be associated with mass extinctions. The idea is that cosmic rays from the nearest supernova could damage the ozone layer, resulting in increased ultraviolet radiation on the Earth's surface and harming life, especially shallow oceanic organisms. Although these theories are still being studied and debated, they highlight the potential impact of distant cosmic events on our home planet. It's a reminder that we're part of a dynamic and interconnected universe. As we look out into space, we're looking not only to the past but also the future. Stars will continue to be born, live, and die, and some of them will end their lives as supernovae. But what does the future hold for supernovae in our Milky Way galaxy? Astronomers estimate that a supernova explosion in the Milky Way occurs on average about once every 50 years. However, most of these supernovae are not visible from Earth because dust and gas block the direct view. The last supernova visible to the naked eye in our galaxy was over 400 years ago, observed by the famous astronomer Johannes Kepler. But rest assured, astronomers are keeping a close eye on potential supernova candidates. These include such stars as Betelgeuse in the constellation Orion and Eta Keel in the constellation Keel. Both massive stars have unusual behavior, leading astronomers to speculate that they could become supernovae in the relatively near future on an astronomical timescale. A recent study has shed new light on the mysterious behavior of that celestial giant Betelgeuse. This star, known for its semi-regular variations, has been the subject of intense scientific scrutiny. In the context of a star such as Betelgeuse, these changes are visible in brightness or intensity of light. The star does not follow a strict cycle of increasing and decreasing brightness, but rather oscillates in a predictable but not entirely regular manner. Researchers have identified 4 different periods in the variations of Betelgeuse: 2, 200, 420, 230, and 185 days. They suggest these periods correspond to the pulsation patterns of the star, in particular the radial principal mode and the first, second, and third overtones. This pulsation analysis, which takes into account the complex interaction between pulsation and convection, suggests that Betelgeuse is in the late stage of core carbon combustion. The study also looks at the previously mentioned event known as the Great Dimming, which caused Betelgeuse's brightness to decrease significantly from December 2019 to February 2020. Researchers speculate that during this period, the effective temperature of Betelgeuse dropped by about 100 K, which may have resulted in significant mass ejection of the star. This event triggered a flurry of observations and analysis aimed at deciphering the secrets of this distant star. The researchers' findings lead to an exciting conclusion. Betelgeuse could be the next star in the galaxy to go supernova. Given the current stage of late-burning carbon in the core, its high luminosity, and complex variations, Betelgeuse is a prime candidate for participation in this exciting cosmic event. The study also notes that the star's high rotation rate as a red supergiant has sparked discussions about its evolution, including the possibility of past mergers with another star as a source of angular momentum. However, it is important to note that predicting exactly when a star will go supernova is extremely difficult because it depends on many factors that are not fully understood. Even if a star has indications that it might go supernova, it could be thousands or even millions of years before it actually goes supernova. But rest assured, when it does, it will be a grand spectacle. The study of supernovae is crucial to our understanding of the universe. These stellar cataclysms are not only endpoints, but also beginnings, saturating the cosmos with the elements necessary for new stars, planets, and possibly life. As we travel through the cosmos, we're constantly reminded of the grandeur and mystery of the universe. Supernovae are a testament to the life cycle of stars, the creation of elements, and the interconnectedness of the cosmos. We have studied their types, the dangers they pose, their impact on Earth's history, and what the future may hold. These celestial events, as destructive as they are also creators. They seed the universe with the elements necessary for new stars, planets, and possibly life. Studying supernovae is not only about understanding these spectacular events, but also about understanding our place in the universe. They remind us we are made of star stuff, that we are part of this vast, dynamic, and constantly evolving cosmos.